Here we have another limits at infinity example problem. And in this example problem, we're going to combine a few different topics that we've gone over in previous videos. So we'll go ahead and get into it where we have our limit as x approaches infinity of e raised to some exponent, which is going to be a function. So the first step is we'll go ahead and consider our exponential limits. So I've summarized them here at the top, but we're really just going to focus on the limits where x approaches infinity, so it'll be these two terms. So what we want to do is we want to try to understand what is happening to our exponent, and we can consider this function as just x. So we want to look at these two portions, and as x approaches infinity, you can kind of consider this as e to the infinity is going to equal infinity. And our other one, as x approaches infinity, e to the negative x or e to the negative infinity is going to equal 0. So we want to know what is happening to our exponent. So in order to do that, we can kind of separate that and write our limit as x approaches infinity of just our exponential function. And so the first step in solving this is we can go ahead and factor out this x term. And what we're left with is this limit as x approaches infinity of 6x plus 1 divided by 5 over x plus 3. And when we evaluate this limit, we'll get infinity plus 1 for our numerator and 0 plus 3 for our denominator. So our solution is going to be infinity. Now we'll go ahead and take this and look at our exponential function to see which one makes sense. So here we have the limit as x approaches infinity of e to the x. So this can be considered as e to the infinity, which is going to equal infinity. So that looks like our solution. We have our limit as it approaches infinity, so e to the infinity, which is basically the same thing that we have. So we have e to the infinity. And so we can go ahead and equate those two things. And so for our solution, we are going to get infinity.